my name is Michael. I'm a product manager at Heroku, and today's session is called Apps at Scale, how applications on Heroku can handle +1 million daily page views. Something about Safe Harbor. Heroku is Safe Harbor compliant now, by the way, so that gets to be important if you have those kind of requirements, but I'll skip that. So you're probably not very interested in me, but I'll just say that before joining Heroku 2 years ago, I co-founded a .NET cloud computing startup called App Harbor. So I've been doing cloud computing for right around 4 years now, both .NET stuff at App Harbor and now more kind of the open source frameworks at Heroku. Right, so what I want to go through today is just to get everyone on the same page. I'm just gonna demo what Heroku looks like and how it works. And I'll do that by deploying a simple app. And then I'm gonna break that app by throwing a bunch of load at it and seeing it not work. And then I'll demo scaling on Heroku to kind of fix that problem and have the app handle a lot of load. Then I'll spend some time talking about some of the new metric stuff that we launched a couple of months ago, which really helps you figure out what your app is doing and make intelligent architectural and scaling decisions. I'll also talk a bit about how we expose metrics for the Postgres data product that we have. And finally, I'll talk about a different way that Heroku lets you scale your apps, which is helping you scale development and deployment even for large development teams in complicated organizations, which gets to be important too. Yeah, just like a brief overview of what Heroku is. There's 3 pillars. There's dynos. And so dynos are the isolated runtime containers that your source code runs in. So they run on Linux inside of LXC containers, where they're nicely compartmentalized from other apps running on the platform. Then Heroku has a great database product called Heroku Postgres, so it's based on the open source Postgres SQL database engine. And we'll give you instance sizes all the way from like small shared multi-tenant databases all the way up to great big honking monsters with hundreds of gigabytes of memory. We'll also let you set up Postgres setup so it has followers, so that even if your main database goes down, you can quickly fail over to one of the followers, which is pretty awesome. And finally, Heroku has a great add-ons marketplace, where if you're not covered by dynos and the database product, you can, from third parties, provision add-ons that get you Redis caches, memcached caching, email add-ons, logging add-ons, so Heroku can emit logs and we'll feed them over to the add-ons that you provision to your apps, and those add-ons are great at kind of analyzing your logs and figuring out what your app is doing. Yeah, and I'm happy to take questions during the talk, so there's these spotlights, so I can't see anything, so you'll have to shout at me if you want me to answer questions, but there's also a Q&A session at the end, whatever you prefer. Pardon? So Heroku runs on top of AWS, Amazon Web Services, but dynos are way different than the general kind of AWS environment. So instead of getting a whole machine that you have to configure and set up yourself, I'll show that in the demo, but with Heroku, you basically just push your code and we take care of packaging it and deploying it and scaling it, so you don't have to worry about kind of server configuration and managing individual servers that goes down and all that stuff. But I'll get to that. Any other questions? Okay. Cool. So I'm just gonna deploy a really simple app. So again, like about 3 or 4 months ago, we launched a new product called Heroku Button, which is like a one-click experience for code that lives on GitHub. So if you're hosting like a sample app or something on GitHub, then you can add a Heroku button and it deploys really easily to Heroku. So you can see there's a bunch of great companies that are taking advantage of this. This is kind of a gallery that we host. So there's Uber and Stripe, in Twilio or Dropbox. They have sample code in there. For this, I'm just going to deploy a very simple app. So this is a GitHub page. You can kind of see it's a Node app. And I'll just deploy that by clicking the Heroku button. So that's going to take me to the Heroku dashboard. I'm just going to start the deployment. And so this is a simple app, but if it had required add-ons or any sort of additional configuration, I would have been prompted for that now. But this is a simple app, so I'm just going to go straight ahead and deploy it. So the source code got pulled from GitHub, and Heroku built it and kind of set up the app in the environment, and it's now fully deployed. So this is the app running live on the internet. So if you were to visit this URL in your browser, you'd get the same result. So that's kind of awesome. So let me just make a quick edit to this app. So the general way to push changes to Heroku is using Git. So if you're a developer, you're probably familiar with Git. It's probably how you collaborate with your coworkers. And the way Heroku works, you collaborate, you could say, with Heroku in the same way by pushing with Git. So actually, we're working on a Dropbox prototype. So if you go to your dashboard, it's not going to show this Dropbox stuff, but it's a prototype we're working on, and it'll be out soon. But I'm just going to do it the good old Git way. So I'm going to git clone the app locally. So kind of imagine the source code went from GitHub to Heroku, where it was packaged up and deployed. And now I pulled the source code down to my local machine. So here it is. Just going to go make a simple change. So this is a Node app that serves up this static HTML. You probably can't see it, but it doesn't matter. I'm just going to make it say something different and commit the changes and push to Heroku. So now I'm shipping the code to Heroku. Heroku is compiling it, packaging it up into a slug, and then deploys it on the platform. So if I go refresh the page now, it says welcome Dreamforce instead of just welcome. So that's the basic workflow of Heroku. So I don't know if you can see, I have kind of two terminal windows going on. I'm going to switch back and forth between them just to show some stuff. I'm going to tail the logs. So all the actions that happen to an app get fed into a log stream. So this is tailing the log, where you can kind of see what's going on. So if I go reload this page a couple of times, then requests show up in the log. So just for kicks, I'm going to scale this to just to show what it's currently at. Right now, it's running one web dyno with my Node app. So I'm going to scale that to 2. And if I go to the log, you can see the API gets a message to scale the web process to 2 dynos, and then the platform boots an additional dyno, which is now up and running. And if I go refresh this page, you can see in the log that those 2 dynos are now serving requests. So there's Web 1 and Web 2. Each of them are getting requests. Yeah. So that's kind of the rudiments of deploying and scaling an app on Heroku. So just to recap what happened, this was me, a developer. I used the Heroku API and CLI to push some changes to Heroku. And the Heroku platform then deployed my code, in this case in the US region. And then the end users, which could be you in this case, it was just me visiting the app in my browser. I visited the app and saw the changes that were deployed. Does that make sense? Yep. So there's an API for this. Like if you don't want to sit around in the console, you can, for example, part of the best way is to provision an add-on, and then we'll feed that log stream into that add-on, and you can go inspect it there, which works really well. Other questions? So basically it meant that I now have, instead of just one dyno, which was default, I now have 2 dynos running identical versions of my source code. Yep, a dyno encapsulates a process running on the platform. So it's kind of a compartmentalized environment where your source code can run, and it has like compartmentalized resources and is isolated from other apps running on the platform. Cool. Okay, so that worked a little too well. So let's try and break this by generating way more load than I can do with by just refreshing the page. So the way I'm going to do that is, if you go to, we have a, so this is the Heroku addons catalog. It's on addons.heroku.com, and it kind of catalogs all the add-ons that are available to apps running on Heroku. And there's a few that can help you generate load and load test your app to make sure that it's up to snuff and ready for any traffic you want to throw at it. And the add-on I'm going to use today is called Blitz. So it'll basically just blitz your app with a bunch of requests. And I'm just going to provision it from the command line. So I do Heroku addons add Blitz. So that's the third-party add-on. So now, like, Heroku contacted that third-party add-on provider. They provisioned the add-on for us, and we got the configuration back. So this is the dashboard view of my app. You can kind of see it has 2 1x dynos, so I scaled it up to 2 dynos, and there's also now this Blitz add-on. So I'll go to Blitz and just get the load test started. So I'm just going to start it off and then explain what's going on. So Blitz says they're testing from Virginia, and I'm just testing the root of the site. So it's running. And what's going on here is there's 2 graphs. The bottom one, the gray one, shows Blitz ramping up the amount of concurrent users hitting the site right now. And the yellow graph shows the response time for the site. Actually, I missed something. Let's see how this goes. So this may actually be successful because I wanted to make a change before throwing load at the app. Let's see. Yeah, this is not going. So what I want to do is, instead of just serving up static HTML, which Node is very fast at, I'm gonna change the app to compute Fibonacci number. Let's see. So this function is a very naive Fibonacci implementation, just to generate some kind of work for the dyno to do. So instead of serving up the HTML template, oops, I'm just gonna have the dyno for each request compute the Fib30, and then return that result in a plain text response. Let's see. I'm just gonna make sure that it works locally. So I just made the change locally and started the app, and it looks like it's computing Fib, so that's Fib30, I guess. Great. So I'll add that and push the changes. Fib, git push Heroku master. Cool. So that's now building and deploying on Heroku. Boom. Let's just make sure that works. So now I'm visiting the site, running on Heroku, and it's doing the Fib thing. That's great. Okay, let's redo the load test. So this should now be way harder. Okay, so Blitz is starting the test. And you can see the response time is longer now. Before it was like 15 milliseconds. Now it's 50 milliseconds to compute Fib. And what should happen is that as load builds on the site, basically the 2 dynos that we have provisioned right now can't keep up. And that indeed seems to be happening. So the response time is climbing. So this is like this has been a normal site with actual users. This is evidence of them having a bad time, right? So responses are super slow. They take more than 500 milliseconds, and you can also see now that timeouts are building up. So basically, they're not getting a response back in time, and are just frustrated and waiting. We can also see down here, yeah. So the orange graph is timeouts. So there's a bunch of timeouts now. And we're now up to about 200 concurrent users, and the test tops out at 250 concurrent users, and basically nobody is getting a sensical response back. So that's not great. Luckily, the app is running on Heroku, and it's super easy to scale it. So I'm going to scale to 20 wet dynos. I can tell the log. So we should, yeah, you can see that the platform booted up a bunch of additional dynos. So we now have 20 dynos ready to be tested. So I'm just going to run the test again. And as you can see, the picture is kind of the same with just a few users because 2 dynos handle a couple of users well also. So the expectation is that the graph is going to stay flat, and we're not going to have all these timeouts and other badness because now we have 20 dynos, and we can handle 250 concurrent users. Any questions about what I just did? Yep.
Are you running all the dynos concurrently, or can you build intelligence so that the dynos can be fired as you encounter things?
So this is not a feature that's native to Heroku, but there's a bunch of great kind of auto-scaling add-ons. So what they do, in fact, is they also consume the log stream. And so they basically analyze the log stream and look at the response time from the dynos. And then they can make pretty good decisions based on the response time that they see in the logs and to scale up or down. There's a great one called HireFire, I think, where you can kind of define what's the maximum acceptable response time that you want for your app. And if it sees greater response times for a period of time in the logs, then it'll bump up your number of dynos, which is pretty cool. So yeah, this is a feature I think we should also have natively. Okay, so this test went much better. So basically nobody saw greater than 60 or 70 milliseconds responses, computing the Fibonacci number. And there were a few timeouts. I don't know. Yeah, I should look into that. But basically a way better situation than before. Does that make sense? Any questions? Yep. Mm-hmm. That's a great question. So what you're asking, like, this is kind of a very simple app, so it's stateless. Each user hitting a dyno, it doesn't matter what dyno handles each request. So in general, what we recommend you do is to try as much as possible to keep the processes running in the individual dynos stateless. So if you do have any state, then you should preferably store it in like memcached or Redis or some other caching, so that the individual dynos can fetch that out. So if, for example, if you store sessions one way and it doesn't fit in cookies for your app, then probably storing the sessions in memcached or Redis is a great idea. Having said that, kind of session affinity and sticky routing is something that we're also looking into, and that'd be interesting. And what that would do for you is basically try to ensure that like the same visitor hitting your site multiple times is served by the same dyno as much as possible. Does that answer your question? Cool. Yep. Yeah, it's just requests are assigned randomly to dynos that are up and known to be in a good state. And so what happens is, like, if a process crashes or if a dyno crashes, then the platform immediately detects that and takes that dyno out of the routing rotation and starts booting up a new one. And when the new one is ready, it goes into the rotation and starts accepting requests.
Are you guys
Oh, so you're talking about like geo routing? Yeah, we don't. That was whoops. That was definitely the. So right now we support running apps both in the US and in the EU, and that was definitely an ambition we had, and it's something that we're looking into. So because we're running on top of AWS, they actually have a bunch of great primitives that we could potentially leverage, but it's not something we can do right now. Cool. Other questions? Yep.
When you have multiple systems of applications, what kind of isolation technology are you for?
So the dynos run inside of Linux LXC containers. So we basically, from way back when, we built our own process isolation mechanism that's based on Linux and LXC containers.
So is that a Docker container or is that your own technology?
So actually, it's our own technology. So Heroku predates Docker by many years. But I think one of the containerization modes supported by Docker is also LXC. So it's the same kind of technology.
Is there a roadmap to come over to the Docker in the future?
So we're looking a lot at Docker and just what to do about it, and in many ways the technologies are complementary. So to me, I spent a bunch of time looking into Docker. To me, the greatest thing about Docker is the great way it lets you compose apps repeatedly, which is similar to what build packs do on Heroku. So when you saw the Node app getting built, that's the build pack running, like taking your source code and packaging into a slug. That's magic to Heroku, and that's also something that Docker does extremely well, and that I think we should look at adopting. Does that answer your question? So we also, other stuff we do, we actually Heroku publishes a Docker image that's the same as a Heroku stack image. So if you want to take apps running on Heroku and run them in the exact same environment on your local machine in Docker, you can do so. So you just get a hold of the Heroku stack image and run your app inside of that. But it's something that we're still exploring. Cool. Mm-hmm. So you wouldn't even need to set that up on Heroku. Basically, like all of the common kind of big open source database solutions are available as add-ons. What was the one you asked about? Yeah, we definitely used to have a CouchDB add-on. I'm not sure it's still there. No. Yeah, we don't have a CouchDB add-on right now, but yeah, there's a bunch of great database solutions that are in the add-on program.
So does that get installed as a part of a separate
No, so basically those services are run by third parties, and the only thing that happens when you click that button is that they provision the resource on their end, and you get the equivalent of a connection string and the kind of the credentials that your app needs to consume this add-on, and then you're good to go. So you don't even have to worry about like how many dynos this is running in. You just purchase the plan that you want, and then you're good to go. Cool. All right. I just had these screenshots in case the demo didn't work. Okay, so that was me demoing horizontal scaling. So basically taking the same apps log and deploying it multiple times to identical dynos to get better performance, more concurrency, and stability to handle more load. We also support kind of vertical scaling. So the 1x dynos that I just used were just have 512 megabytes of RAM. So they're fine for a small node app like the one I deployed. But you can also scale to 2x dynos, which have a gig of RAM, or you can even get px dynos, performance dynos, which have, I think it's 6 or 7 gigabytes of RAM and a bunch of CPU power. And you can really make your app go fast. When you're running in bigger dynos, depending on the memory profile of your app. You can also run multiple processes of your app inside the same dyno. So if you have a PX dyno and you're running, say, Ruby Unicorn or something, then you might run 20 workers inside of that one PX dyno just to get additional concurrency and performance out of it. Other stuff that people tend to do is moving long-running tests to background workers. So the app I just showed just had web workers, but you can have additional process types. So I might have a kind of worker pattern where I have a bunch of workers where the web workers queue up tasks in the queue, and then the workers will pick those tasks out of the queue, out of the kind of request serving context, and handle those. So say, for example, the task of sending a confirmation email when a user signs up. It's not really ideal to do that in the request response cycle. So what we recommend people do is, like, the user signs up, you enqueue a task to send the email, and immediately return the response to the user saying, thanks for signing up, your confirmation email is on the way. And then a background worker picks up that task and sends the email along. And it's just a better overall experience for your user because they immediately get the response back. And also it's better for your kind of application architecture because that web dyno immediately becomes free to start serving other requests instead of waiting for some SMTP server to ship the email along. People also start caching stuff either in Memcached or Redis. So for example, in my case, it looked like a bunch of people were very interested in what FIP30 was, so I could probably just have cached that result in somewhere and repeatedly serve that out of a cache instead of computing it recursively each time. We also recommend people use CDNs. So kind of typically, dyno resources on Heroku are going to be scarce. So if your app has a bunch of CSS or images or JavaScript files, ideally your dyno should not be consumed by serving those up. And we recommend people use a CDN like Amazon CloudFront to serve that stuff. Finally, not really a scaling feature, but a really cool artifact of Heroku. We have something called pre-boot. So imagine, like, I have my 20 dynos running. Usually, if I did a deploy, without pre-boot, the way it works is that we kind of spin up the new dynos, point the routers at them more or less immediately, and start winding down the old dynos, running the old version of your code. So this is when you deploy. You have both the old version and the new version. And Heroku is pretty gentle about the way we shut down the old dynos. We give them kind of a bit of time to finish serving requests and whatever else they need to do to wind down. But it can be kind of jarring. So with pre-boot, what we do is basically when you deploy a new version of your code, instead of immediately shutting down the old ones, we just spin up 20 new dynos running your code and kind of wait around for 2 or 3 minutes to make sure that those are up and running and ready to serve requests. And only then do we start sending traffic to them and winding down the old dynos, which is super cool and something that'd be way harder if you're managing your own infrastructure. So imagine, like, if you have your own data center, you more or less, either you have to have like 20 additional servers or however many servers you have, which is not really practical, just for those quick switchovers during deploys, or you would have to switch over your 20 servers individually, which means that deploys take way longer, and you kind of have to write your code in a way that it has to be able to tolerate 2 versions of your code running concurrently as you do the rolling deploy across 20 servers. Pre-boot is way more elegant, and it's something you get just due to the elasticity of Heroku and how easy it is for us to spin up and run additional dynos. And really what this gets you is the ability to deploy with confidence. Like even if you have super high traffic apps, you can deploy and push changes to them frequently and confidently. So in aggregate, the Heroku platform handles way more than 5 billion requests per day. There's more than 3 million apps and a bunch of add-ons. So I mean, we get people approaching us trying to figure out whether Heroku is right for them, and even if they have very ambitious goals for their app, maybe they're expecting it to be wildly successful and serve like 10 million requests a day, and they're worried that whether that's gonna fly on Heroku. It's really a drop in the bucket compared to the aggregate platform throughput that we have across all the apps that are running on the platform. So like Heroku will even, like we run a bunch of apps, for example, that are featured in Super Bowl ads. So during the Super Bowl, I kind of like, I don't particularly care for football, so I usually just watch the Heroku dashboards. It's always interesting when like a particular ad goes on and a bunch of traffic all of a sudden comes in because people are wanting to get some sort of deal or whatever's running on in that app. And you can see load spike, but we handle it gracefully. So it's just that if you go to the campground over in Moscone North, there's a great Heroku booth where we're profiling a bunch of the apps that run on Heroku. And these are some of the other ones. Probably my personal favorite of these are Urban Dictionary. People generally familiar with Urban Dictionary, like kind of explains slang terms. And it's a really cool website. And I think it's actually one of the, either it's a top 100 or top 500 site on the internet. It gets a lot of traffic, and it runs on Heroku. And I think it's pretty much one guy running this giant website. And the reason he can do that is because he's leveraging Heroku. Like he doesn't have to wear a pager or maintain all this infrastructure and worry about servers going up or down. He's farmed all that out to Heroku, and he's doing pretty well. Yeah. Okay. I don't have a bunch of time yet left, so I'm just gonna breeze through some of the new metric stuff that we launched a couple of months ago. So this is a dashboard again. This is showing a slightly more sophisticated app. So probably my colleagues are scaling this up and down because it's also one of the demo apps we use at the booth. But this has like 10 1x dynos right now. It's going to reload. Oh, it's still the same. It has a couple of databases installed, a CDN, New Relic, like a great logging and analytics add-on. And there's also a big Redis cache installed, it looks like. Anyway, what I wanted to show is the metrics view. So what this is kind of like a time scale. So going from Tuesday, yeah, I guess just 24 hours back right now. Showing errors that are happening. That's the red dots with links to documentation. And then we're kind of graphing out the response time and the request throughput of this app. Also seeing how many of the responses failed. So it looks like there was a dent in uptime here. There were a bunch of failed responses. And CPU use and memory use. And we even, I think the coolest feature is we kind of provide, based on this intelligence and us aggregating it and the experience that we have running apps like this, we can prompt you with kind of alerts and at things that seem to be going wrong with your app in a pretty intelligent way, which is pretty cool. But this is more or less all based on the kind of the same logging stuff I showed before, and then just us being intelligent about analyzing it. And yeah, and we're building additional alerting and features around this all the time. Cool. Any questions about metrics? No. Okay. I still have like 5 minutes left. So let's see. Oh, I'm sorry. I'm an idiot. It had a screenshot, so I was confused. Okay, so this is a screenshot from, so the metrics I just showed you, that's just kind of the dynos running. This is from the Postgres, or the Postgres database. So, and it's showing the expensive query analysis tool. So basically, if you're running a Postgres database on Heroku, the system will continuously monitor the queries that are going through the system and keep track of which ones are slow, which ones are very frequent, and provide you with suggestions for queries you might want to optimize. So, and it'll rank them based on badness. So basically the top query showed here is, it looks like it's super frequent and it's also fairly slow. It might be a good idea to optimize that. And it's again like something that you would probably, if you were just like a lone database admin, you probably wouldn't be building this on your own time. But because Heroku runs 800,000 Postgres databases, it makes sense for us, and we have the economies of scale to go and build this kind of tooling and make it available to people. So this is from a terminal. It's a tool called PGDiagnose, and it's run against a database, and it has kind of a few red alerts about index hit rate. So it keeps track of index use of the Postgres database, and it looks like the hit rate here is only about 90% in aggregate, which is not great. It means that 10% of queries have to go to disk to get the result. And it also lists the indexes that have a bad hit rate. Then there's some yellow alerts. So it looks like there are 4 never used indices. So that's kind of bad because the database has to spend time as records are inserted keeping those indices updated. And if they're never used, they just inserts take longer, and they take up a bunch of either disk space or memory. So those could probably be gotten rid of. And then there's a bunch of stuff that's green. Which is good. Cool. Then the final stuff, so that kind of covered the runtime, all the dyno and metric stuff, and the metrics that we provide for your database, which lets you make good decisions about how to optimize your app and your app architecture. So we also help you scale to big kind of development teams. So this is showing, you might also have noticed when I was in dashboard before, but this is kind of showing the orgs view, which is on the left sidebar. So orgs are a way for you to pool and group apps together so that you can track resource usage and manage access to apps. So for each of these orgs, you can see like we have a Heroku org, which contains most of the apps that we run on the platform ourselves. And then the addons team has an org, and Vault, the guys who do building, have their own org. And it's a way for us internally to manage access to those apps and also figure out like what teams are using a lot of resources and what teams are being good about curtailing platform use. I'm not gonna talk about pipelines because I'm out of time. That's about it. So kind of the 3 things I want you to take away. Like the 3 ways that Heroku helps you scale. We have dynos and a super scalable platform, which really makes it easy for you to provision the resources that your apps need to serve requests and be a good experience for your users. We have a great data product in Heroku Postgres that lets you scale your database needs. And finally, we also let you scale even if you have a giant development team with a complicated software development life cycle. We support that too. Cool. That about wraps it up. I'm happy to take questions. I'll stick around for a bit, or you can ping me on Twitter or send me an email. Happy to take questions. Any questions in the room? Oh, thanks.